Hello and welcome all to this YouTube session. This is Atul from Edureka and our today's session is dedicated to all the learners who are interested in switching over to Python. No matter whether you're in your college or you are a working professional at a top-notch multinational company, this tutorial is dedicated to all of you who are planning to learn Python. I'd say that you have made a right decision by opting to learn Python. You'll find a large open source community out there for Python. Now, since Python is open source, so there are plenty of independent programmers out there who are building libraries and adding functionality to Python. Let's get started with our tutorial and let me give you a quick overview of agenda for today's session. During the session, I'll talk about Python from scratch. I'll try to cover almost all the basic and some of the tricks related to Python. The topics would include introduction to Python 3.0, various Python features, operators in Python, data types in Python, and finally we'll end this session with flow control function in Python. Look, I want to make this session fully interactive, so I'd suggest that please get your laptop ready with Python 3.0 installed in it. If any extra dependencies are required, we'll install them then and there during our session. All right. So without delaying any further, let's quickly start with our session with a brief introduction to Python. Python is an open source, high level, and object oriented programming language that was created in the year 1991 by Guido van Rossum. You know what? Python is named after a sitcom, Monty's Python Flying Circus. It seems that the creator was highly inspired from the show. And the reason why Python is so popular today is all because of its clear syntax and easy readability. Several websites states that Python is one of the most famous programming language of 2018. Because of its implementation and simple syntax, it makes your code more readable. When you compare Python to other programming languages like C++ and Java, you'll find that, like in case of Java, you have to write 4 lines of code just to take input from the user, right? But in case of Python, all it requires is 1 line of code. Alright, so this was some introduction to Python. Now let's proceed and see what experts or what Python programmers all over the world have to say about it. First comes, Python is easy to learn. Well, yeah, Python is easy to read even if you are not a skilled programmer. Anyone can start working with the language. All it takes is a bit of patience and a lot of practice. But yeah, don't get deceived by its lucidity. Python is not just limited to basic usage. In today's world, it powers some of the world's most complex application and website. Python syntax is very clear, so it is easy to understand the program code. And Python is also often referred to as executable pseudocode because its syntax mostly follows the convention used by the programmer to outline their ideas and to describe it to other programmers. Alright, so this is how Python is simple and easy to learn. Next is Python is free and open source. Python is completely free to use and has an enormous user community. This means that no matter what problem you are trying to solve, chances are that there is already strong documentation, tutorials, guides, and examples to help you along your way. There are numerous integrated development environments and other development tools to choose from, and 1,000 of open source packages available to extend Python to do anything you can think of. Alright, so this is how it is free and open source. Next is high-level language. Well, Python is an example of high-level language. It allows you to write programs in simple and understandable language which is easy to read and understand. You may have heard that some people call Python as an interpreted language. So what does this mean? Well, it means a compiler converts the .py source file into a .pyc bytecode for the Python virtual machine. And finally, this bytecode is executed by the interpreter. Alright, so this was about the high-level language. Next is supports different programming paradigm. In general, there are 4 different types of programming paradigm that are used in Python. The first being the object-oriented, which states that you can create classes and objects in Python. Next is procedure-oriented, which says that you can perform step-by-step execution and you can even group your code as function. Third is functional. No matter what you are writing in Python, your every statement would be treated as a mathematical equation. The main advantage of using this approach is that it allows you to perform parallel processing. And the final one is imperative, which suggests that the computation in Python is performed as a direct change to the program state. It is generally used for data manipulation of data structure. Alright, so this was about how Python supports different programming paradigm. And the final one is Python is portable. Well, yeah, Python is portable as it can run on many Unix variants on the Mac and on various versions of Windows. Alright, so this is what experts have to say about Python. So moving on ahead, let's see who is using Python. Well, be it machine learning or creating a web application or even a desktop application, Python is the one which many tech giants in the market like Google, Dropbox, Netflix, YouTube, Raspberry Pi are using it for their development. Well, I think I don't need to mention that since a lot of companies rely on Python language. So you definitely have a chance to make a good money as a Python developer, right? Well, enough with the background check of Python. Let's quickly install it and let me show you how easy it is to write codes in it. So open your browser and redirect to www.python.org/downloads. You can see that we have a download option up here. Just click over it and your download will start. Most people are confused at whether they should go for Python 2 or Python 3. In the past, there was a debate in the coding community about which Python version was the best one to learn, Python 2 or Python 3. Well, I'd say that Python 3 is the future, and many popular companies like Instagram and Facebook have already shifted from Python 2 to Python 3. Even talking about their libraries, today most other developers are creating libraries strictly to be used with Python 3. There are many older libraries for Python 2, but they are not forward compatible. Yes, it is possible to port a 2.x library to Python 3.x, but yeah, it can be very difficult and complicated, and it's definitely not a Python for beginner type of activity. So I'd say that as a beginner, you must avoid spending time on learning the obsolete older version and go with the future, which is Python 3. All right, let's just click on it and let's install it. I have already installed Python from my Windows. You can just click over to the downloaded exe file and just follow the steps and Python will be installed on your system. All right. So after installing Python, you would have three options. Either you can go with a Python command line interface and write your codes on it, or you can use any text editor like a notebook, or you can install a Python IDE. And IDE stands for Integrated Development Environment. A Python IDE will give you a proper programming environment which combines for coding facility with a debugging environment. For this tutorial, I'll be using Jupyter Notebook, which is a web-based application based on server-client architecture, and it will allow you to write your Python codes on it. Alright. Well, you should try this Jupyter Notebook because it's provide you with an easy-to-use interactive data science environment across many programming languages that doesn't only work as an IDE, but also as a presentation or educational tool. It's perfect for those who are starting to learn out with data science or Python. Alright. And yes, if you're trying to install Jupyter Notebook and Python, I would strongly recommend you to use the Anaconda distribution, which includes Python, the Jupyter Notebook, and other commonly used packages for starting with Python, scientific computing, data science, and machine learning. So let's visit www.anaconda.com/downloads. So you can see here we have a download option over here. So just click over the downloaded exe file, follow the series of steps, and your installation will start. So now I'm assuming that you have installed Anaconda on your system. I have already installed Anaconda on my system. Let me just open it and show you how does it looks like. Anaconda Navigator. So this is how the Anaconda Navigator looks like. From here, I'll select the Jupyter Notebook and I'll hit the launch button. My Jupyter Notebook will open under the local host. As you can see here, it opened on a local host with a port number of 8890. Alright, so this is my Jupyter Notebook. So now that we have set up our coding environment, let's start coding in it. So I'll create new and I'll select Python 3 from it. So this will redirect you to the Python notebook page where you can write all different sorts of Python codes on it, ranging from a beginner level to advanced one. So now that we have set up our environment for coding, let me just give you a glimpse of how easy is Python. So do you want to perform some addition as simple as like 2 plus 3 executed? You'll get the result 5. It's as easy as that. So let me teach you more of it. So our first topic is how to assign value to a variable in a Python. Assigning values to variables in Python is very easy. You don't have to add any data type before a variable. Just specify the name of variable. For example, var equal 10. Alright, so depending on the data, Python will automatically detect the data type of your variable, which in this case is integer. Alright, let's see some other examples. Suppose name equals John. So this is my string type, but I'm not specifying any data type behind that name, right? And when I'll execute it, Python will automatically detect that, yeah, this particular variable name is of type string, or salary equal something like 2000.234. All right. So when I execute it, Python will not throw any error regarding the data type. It will automatically take salary as a floating type variable. Okay, now that you know how you can assign a value to a variable, let's see how you can have multiple assignment to the variable. All right. Suppose you have three variables, a equal 10, b equal 10, and c equal 10. So instead of initializing all three variables with the same value, what you can do, you can write like a equals b equals c equal 10. This is multiple assignment. So you can just write a equal b equal c equal 10. All right. This is same as a equal 10, b equal 10, or c equal 10. Now, what if you have to assign different values to each variable? So similarly, instead of assigning the value one by one, you can just write like x comma y comma z equal value for x will be 10, value for y is 20, and value for z is 30. All right. Let's print any of these two variables and check if we are correct or not. So let's print b and z. So print b and print z. Yeah. So we have 10 and 30 as the output, means multiple values have been assigned. All right. Next is Python token. Now that we know how to assign values to a variable, so let's move and start our discussion with some of the basics of Python. We'll start with Python token. So what is this Python token? Well, Python token is a basic component of the source code. The characters are categorized as one of the 5 classes of the tokens that describe their function. Keywords, identifiers, literals, and operators. So let's discuss them one by one, starting with keyword. These keywords are some of the reserved words which are designed for a specific purpose. You cannot use a keyword as a variable name or an identifier name. Some of the keywords in Python include if, while, for, etc. These words in Python have a specific purpose and has a specific meaning to it. Alright. Next is identifier. So what are these identifier? Well, identifier is the name which you give to your variable or your function or your class. For example, if you are defining num equal 10, so then the word num is identifying the variable and hence the word num is an identifier. Before you start naming your variables or methods or class, you must know that there are certain set of rules or guidelines for naming an identifier. Let's see them one by one. The only special character allowed for naming the identifier in Python is underscore. You cannot use at the rate and dollar or any other special character as an identifier. The second point is you cannot use keyword as an identifier name. This I have already told you before. The third point is Python is case sensitive, which means that capital A is different from small a. Both will be treated as two different identifiers. For example, I am declaring a variable capital A equal 10 and small a equal 20. So if Python is not case sensitive, then the value of a should be updated to 20. But let's see whether it's updated or not. Print a and print capital A. So as you can see here on the screen, we have 20 and 10. For small a, the value defined was 20, so it's giving 20, and for capital A, it was 10. All right, so Python is case sensitive. And finally, your identifier must start with an alphabet or an underscore. It cannot start with a number. It's like you cannot have an identifier name as to num underscore key. All right, let me show you this with an example. Like I'm mentioning key equal 10. This is correct. All right, this will execute. Now, suppose I am defining a variable name as 12 key equal 10. So when you execute it, you'll find an error like invalid syntax. So as the rule of naming the identifier says that you cannot start the identifier name with a number and you must start either with an alphabet or underscore. So if I'll add underscore at the beginning, so this would work fine. Yeah, it worked, right? So this was all about the identifiers. Next is literals. Literals are the constant used in Python, or you can say that literals are the data given in a variable or constant. There are 4 types of literal in Python: string literal, numeric literal, Boolean literal, and special literal. So starting with string literals. You can create this string literal by enclosing the text in the quotes. Both single and double quotes are allowed in a string literal. Let me show you with an example. For example, name equal John. This is written under double quotes. All right. Or name 2 equals Jonathan under single quotes. Now, if you print it, you won't get any error. print name plus name2. So you're getting John and Jonathan. So here's a trick in printing. So when you're printing things, so what does it print? Print the string. So the name variable is already a string. The name2 variable is also a string, but I want to add some space over there. So I'm defining a quote with a blank space in it. So the blank space within the double quotes is treated as a string. So we are concatenating all the three with a plus symbol. All right. So let's just print it. Name plus empty double quotes plus name2. So you can see that we got the output as John space Jonathan. So which proves that for a string literal, we can use both the double quotes as well as the single quote. Now, what if you have multiple line of input? So how will you print that? Well, for that, you have to enclose your text within triple quotes. Let me show you this with an example. Multi-line equals, you have to enclose it within triple quote, 1, 2, and 3. Write whatever you want. Suppose this is my first line. Then this is my second line. Then again my third line. And again close it with triple quotes. Let's print it and verify whether we are correct or not. So multi-line. And when you're executing it, you'll get the output as first line, second line, and third line. So it's working perfectly fine. So for multiple line declaration, you could enclose your string into triple quotes. Fine, so this was all about the string literals. Later in this session, we'll see what are the various other functions that you can perform on the string literal using some of the Python's existing library. For now, let's move ahead. So let me just give you an overview of numeric literal. A numeric literal is a character string whose characters are selected from the digits 0 to 9, signed character plus or minus. Remember that you can use only one of them at a time, as the number can either be positive or negative. It cannot be both, right? And finally, the decimal point. If the literal contains no decimal point, it is an integer. If your number is too long, we add capital L or small l at the end of the number, and it makes it as a long integer number. If the literal contains the decimal point, it is a float. But remember that you can use only one decimal point in one number. Have you ever seen a number with more than one decimal point? For your information, I'm not talking about the IP address, right? Okay, fine. By the way, in Python, the value of integer is not restricted by the number of bits, and it can expand to the limit of the available memory space. And since the value of integer depends on the available memory, so no special arrangement were made in Python for storing large numbers. Any doubt up till this portion, anyone? If you have, please add it in the comment section below. All right. So let's move ahead. So next we have is Boolean literal. These Boolean literal have just two values, true or false. One more thing. Remember that these true or false are also a keyword, so you cannot use them as an identifier. They are generally used when we are dealing with some condition whose outcome is either true or false. All right. Finally, we have the last type of literal, that is special literal. Well, in Python, we have just one special literal, that is none. This literal is used to specify the field that is not created. So have you heard the word null keyword from C, C++, or Java? If yes, then the equivalent of null in Python is none. All right. Most often, you want to perform an action that may or may not work. So if you are using none, you can check the state of action later. For example, we would like to connect to a database, but we don't know if the authentication details are correct or not. So we'll try. If the database connection fails, it throws an exception. So for this case, you have to use none. It's like you're defining a variable database under connection and you're assigning the value none to it. All right. And you're defining a try block, and in try block, you're changing the value of data underscore connection to connection established. And finally, when you are moving out of the try block, so what you're defining your if and the else part. The if part consists that if the connection to database is still none, then the connection could not be established, or else the connection is established. All right, let's move ahead. Okay, I hope that you have understood about literal. So let's move ahead to operators. Well, operators are some specific characters having some specific tasks and functions to perform. And based on the function, the operator have been further segregated into 7 different types of operators. the arithmetic operator, assignment operator, comparison operator, logical operator, bitwise operator, identity operator, and membership operator. Let's discuss them one by one. So starting with arithmetic operator. Arithmetic operators are the one which is used to perform some arithmetic calculation. It takes two operands and perform operation on them. For example, 1 plus 2. So the character plus over here is treated as an arithmetic operator. And when you execute it, the result would be 3. So 1 and 2 here are the operands, and plus, that is the arithmetic operator. Other arithmetic operators are minus, like 2 minus 3, or 4 divided by 2, or 2 mod 1, anything. Next is the assignment operator. These assignment operators are used to assign a value to a variable. Characters which comes under this operator are equal to, plus equal to, minus equal to, or multiplication equal to. For example, if you're writing a equal 10, so equal to here is your assignment operator and is used to assign a value to a variable a. Alright. Next is the plus equal to. Now let me show you what is plus equal to and how you can use it. Well, this plus equal to is a shorthand which means add and assign to self. For example, a plus equal to 10. Alright. So this is equivalent to a equal a plus 10. So what do you think the expected output should be? Now, since I have already assigned the value of a equal 10, so what I'm doing over here is a equal 10 plus 10. So my expected output is 20. So if you print it, so let's print and check whether we are correct or not. So as you can see, my output is 20, so it confirms my explanation. Similarly, you can perform a minus equal to 10. What do you think the expected value should be? Guess it. So what do you think the expected output should be? Is it 0? No, it's wrong. It's not 0, because now the value of a is updated to 20. So when you will print it, so it will subtract 10 from the updated value of a. That is, it will perform 20 minus 10, and the output would be 10. Next we have is comparison operator. Well, these operators are used to compare values and return true or false as the output. It includes greater than, less than, not equal to, or double equal to. Alright. For example, 11 is greater than 10. Agreed? Let's see the output. It's true. Alright. 11 is greater than 12. It's false, right? So when you execute it, you'll get output as false. Next, 11 is not equal to 10, right? So you will get the expected output as true. Alright. So I hope that you got what a comparison operator is. Moving on ahead to the logical operators. So these logical operators are used to perform some logical calculation like and, or, not. For example, a equals 7 is greater than 6 and 2 is greater than 1. So this is true. So true and true. What do you think the result should be? So true and true, it's true. So if you print it, print the value of a, what you will get? You will get true. All right. So how do you think this AND is working over here? So this AND is performing the binary calculation. All right. So if both are true, you will get the output as true. And if even one of them is false and you're using AND operator with them, so it will give you output as false. For example, a equal 7 is greater than 8. This is false. And 2 is greater than 1. This is true. But when you print the value of a, you will get the result as false because 7 is not greater than 8. All right. It is performing basic binary calculation. True and true results to true. True and false result to false. False and true result to false. And false result to false. So if you are using an AND operator, you'll get true in only one case if both the condition or the comparison is true. Alright. Next is the OR operator. Let's see the same example. Like a equals 7 greater than 6 or 2 greater than 1. So when you print it, what do you think the expected value should be? Obviously it would be true, as both are true. So in case of OR, you'll get a false value only if both the condition or comparison are wrong. So this is true. A equals 7 greater than 8. This is false. Or 2 greater than 1. And when you print the value of a, so what do you think the expected value should be? True or false? Well, it would be true. Because the or operator, it works on if either of the condition or the comparison is true, it will give the result as true. The only condition where your or operator would give you a false output is when both the condition or the comparison is false. Like a equals 7 greater than 8, this is false, right? Or 2 greater than 3, both are false, right? So in this case, both your condition are false. So when you will print the value of a, you will get the output as false. Fine. So this was about or. Next is the not operator. Well, this not operator is used to return the complement of the result. Alright. For example, a equals not of 7 greater than 8. So 7 greater than 8, it's false, right? So not of false is what? True. So it will give you the result as true. Alright. So this was all about the logical operators. Next is bitwise operator. This operator includes AND symbol, pipeline symbol, tilde symbol, double greater than or double less than. This double greater than is known as right shift and this double less than is known as left shift. Let me show you with an example how this works. Let's start with the pipe symbol. What does it mean? So 7 or 5. 7 pipeline 5. It's nothing but 7 or 5. When you perform a OR of 7 plus 5 in calculator, you'll see that 7 or 5. It will result to 7. How it's doing that? First, it's converting the 7 into its binary part. That is nothing but 111 and 5 into its binary part, that is 101. And when you perform the binary addition on it, it's like 1 plus 1 is nothing but 1. 1 plus 0 is 1. And 1 plus 1, it's again 1. So the result of which is 111, which is nothing but 7. Alright. So this was about the pipe operator. So the next is AND operator. So it's like when you're performing 7 and 5, what it will result to? It will result to 5. And how it's giving the output? Let me show you. Let me open a notepad or something. Paint. It's like 7 converted to its binary form is 111. Whereas 5 converted to its binary form is 101. And when you're performing AND operation on it, so 1.1. It's like 1.1 is what? 1. 1.0 again 0 and 1.1 again 1. So it is nothing but in decimal it's 5. So the result of 7 and 5 equals to 5. Alright. Next, moving on ahead, we have left shift and right shift operator. Let's see their use one by one. For example, I'm mentioning 10 double right shift to 2. So what its output is? 2. Let's see how we are getting this output. Let's clear this out. So we have 10 right shift to 2. And when 10 is converted to its binary form, it's 1010. So what you want to do here, you want to shift 2 bits towards the right. Alright. So it's like pushing your bits from left towards right. So when you're pushing 2 bits towards right, what you will get? It's like 0010. Alright. The last 2 bits will be ignored. Alright. So the conversion of this is nothing but 2. So this is why 10 right shift to 2 results to 2. Okay. Next we have left shift. 10 left shift 2. And the output is 40. Are you getting 40? So let's see how we are getting 40. So this time 10 left shift 2. Similarly, we are converting 10 to its binary form. That is nothing but 1010. Alright. So now we want our 2 bits to shift from right to left. So we'll add double zeros at the end. So when converted to its decimal form, we'll get as 40. Alright. So there's a shortcut of calculating the left shift and the right shift. While you're performing a left shift, the shortcut is if you want to perform a left shift of 3 bits. So just add 3 zeros at the end. And the shortcut of using right shift is that just remove 3 bits from the end and add 3 zeros at the starting. That's it. Alright. So this was about the bitwise operator. I hope the bitwise operator is clear to you guys. In case you have slightest doubt, add it to the comment section below. For now, let's move ahead and learn about identity operator. Well, these operators are used to test if 2 operands share an identity or not. Is and is not are the 2 keywords which are used as an identity operator. For example, as you can see here on the slide, we have x equal 5. So x is 5. That is true, right? And again, if you are mentioning that x equal 5, So if we are using the keyword x is not 5, that is false in this case, as we have already mentioned that x equals 5. All right. So this was all about the identity operator. Next is the membership operator. Next and the final operator in Python is membership operator. This operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, a string, or a tuple. I know some of you might be thinking, what is this list or tuple? Then guys, just be a bit patient. I'll teach you about them in detail in this session. For now, just understand that the list is same as the array. And this membership operator is used when you want to check if a certain element is there in the list or not. In and not in are the keywords which are a part of membership operator. For example, as you can see here on the slide, we have a list as pets, and the list includes three elements: the dog, cat, and ferret. So first let's use the in operator. So we are using fox in pets. It's false, right? There is no fox in pets, as we have just dog, cat, and ferret. So it's returning false as a result. Next, let's search for cat. So cat in pets, it's returning true, as the cat is already there in the pet. There's one more use of this membership operator. It can also check whether a particular word is present in a string or not. For example, the word me in the string disappointment. So it's returning true, as the word me is already present there. MENT. So this was all about the operators and the Python tokens. Next, we'll learn about the data type in Python. Well, Python has mainly two data types: immutable and mutable. Mutable data types are the one which can be changed, and immutable data types are the one which cannot be changed or modified. Immutable ones include numbers, strings, and tuples, whereas the mutable data types includes lists, dictionaries, and sets. Let's discuss them one by one. So starting with numbers. As I've already told you under the numeric literal part, that Python has four different types of numeric literals: integer, long integer, floating number, and complex number. You don't have to specify the data type of variable while you're declaring it. Python will automatically convert a number from one data type to another if it needs. Don't worry, if you want, you can even explicitly convert one data type to another using the function of int, long, float, or complex. So let's move ahead and see how we can find the data type of a variable. Let's declare some variables and check their data type. So we have a equal 10, b equal 10.23, and c equal a string. Now let's find the data type. So print the type of A, then print the data type of B, and then print the data type of C. Let's execute it. So my first variable A is of type int, the second variable B is of type float, and the third variable is of type string. So this proves that Python automatically detects the data type of the variables. Let's move on ahead in data type in Python. Next is strings. So anything written under a double or a single quotes is a string. Let's perform some operation on string and understand it in detail. So string is anything which is defined under a single quote or a double quote. Let's define some string. For example, my string 1 is Python tutorial. String 2 is, let's define our second string as welcome to Edureka. So these are my two strings. Now let's perform some functions on it. Now what if I want to extract the first letter from my string? So what I'll do, print string first character. Let's see what it's print. So it gives you P. For example, you have a string over here like Python. So what it actually does is it indexes each of the characters. For example, P would be indexed as 0, Y as 1, T as 2, H as 3, O as 4, and N as 5. So if you want to access any of the character, you can just access it using their index number. Now suppose if you want a substring as tutor from the word Python tutorial. So how will you do that? So let's see. So print string 1 starting from which index? I want to start from T. So the index of T is 0, 1, 2, 3, 4, 5, 6, and 7. So it will start from 7 and the word tutor ends at what? 7, 8, 9, 10, 11, and 12. So it ends at 7, 8, 9, 10, and 11. So your range of the word is 7 till before of 12. And when you execute it, you'll get your result as tutor. Next is Python uses a special syntax to format multiple strings and number. For example, you have a variable like word equal ABC and its count, you're defining it as 40. For example, I have to print the word appears count number of times. So how will I do that? So there is a syntax in Python, like the word %i appears %i number of times. And then close it. The %s, it tells that the value of first variable is of string, and %i, it tells that my next value is of integer type. Let's execute it. So you can see that it's giving me the result as the word ABC appears 40 number of times. Now, what if you want to take input from a user? Like print, enter your age. You want user to write his age. So how will you do that? So there's a function as input, like age equal input, and it's done. Just execute it and it will ask to enter your age, like enter your age 27. Now you can modify your code using the previous trick which I've already taught you, like print your age is age. Enter your age 27. So your age is 27. There are some predefined set of functions in string. Let's learn about them one by one. The first is find function. This returns the position of the string. For example, I have a string defined as string1 equal find me. And what I want to do, I want to find the position of me in the string find me. So what I'll do is, so str1 dot, I'll use the function find. What I need to find is me. Let's see what it has the output. So it's 4 and it's correct. 0, 1, 2, 3 and 4 is this starting position of me. Now what if I find a substring which doesn't even exist in that string? For example, I'm searching here for the word apple in the string find me. So it will result to -1 as the word apple is not present in that particular string. Next is replace. This string, as the name suggests, it is used to replace something. For example, I have a string 2 equal replaced and I want to remove the ed from the last part. So what I'll do, str dot, I'll use the replace function, and what I want to replace ed with what? With e. And when you execute it, the word ed has been replaced by the word e. Next is split. So this function creates a split on the basis of a character. Let's define another string. Suppose we have string as word1, word2, word3. But what I need to do is split on the basis of commas. I need to separate that word. So I'll use str3.split on the basis of what? Comma. So what it will do, it will show me 3 different lists of words. Word1, word2, and word3. All these 3 would be treated as 3 different strings. Next is the count function. For example, str4 equal Edureka. And I want to count the number of e's in the string Edureka. So str4 dot count. Let's count what? I want to count the number of e. So it's giving 1. As I told you that capital E and small e would be treated differently. So next string we have is upper. Now what if I want to convert this Edureka to its uppercase? So let's take str5 equal str4 dot upper. Let's see its result. So you can see that each character of the word is converted to its uppercase form. Now once the entire word is converted to its uppercase form, so when you run the count function on string 5, str5.count, and you search the total number of e's in it, you'll get as 2. You'll get the output as 2. Now let's move ahead and learn about the max and min function. This max and min function returns the character with the maximum or minimum ASCII values. For example, string 5 still has Edureka in it, right? So let's find the character with the maximum ASCII value in the string Edureka. So max of str5. It's u, edureka. Okay. So u has the maximum ASCII value. Now, what if I update my string 5 with a value like edureka @# Now, what if I want to check the minimum ASCII value in it? So let's check minimum of str5. So let's see what you are getting. It's hash. So the minimum ASCII value in the string edureka @# and dollar is hash. Hash is having the least ASCII value among these characters. So this was all about these strings. Next is tuple data type. So these are a group of values within the parentheses, and since they are immutable data types, so the values within the tuples cannot be changed. For example, my group equals A, B, C, and D. This is an example of a group. Now let's move ahead and perform some operations on it. So first is concatenation, that is add two strings or character. First, let's define our tuple like my group equals within parentheses A, B, C, and D. So this is my group. And my first task was to perform concatenation, that is add string or character. Now, what if I want to add E to it? So my group plus equals, I want to add character E with a comma. Don't forget to mention comma over here. If you are using Python 3, don't forget to mention comma at the end. Now, if you execute it, your group will get updated. You can verify this using the print command. So print my group, let's see. So you can see the updated value over here. Next operation is repetition. That is duplicate the string or character by a given number of times. Let's do that. Let's duplicate our group. So my group, and I want to duplicate it. So multiplied by 2. So you can see the output as A, B, C, D, E, and again the repetition A, B, C, D, and E. Next is indexing. It shows the indexed character or the string. For example, I want the third character from my tuple. Print group the third character. And what I'm looking for is the third character. So A is indexed with 0, B with 1, C with 2, and D with 3. So we got the output as 3. Next is slicing. That is shows a specific set of index character or string. So for example, I need to see last 4 values of my tuple. So how can I do that? So my group start from first character and it will end till last. So just leave that and you'll see that you got the output as B, C, D, and E. It starts from 1 and colon, and if you don't specify anything, that means it will end at last. Similarly, if you will write my group, if you don't specify the starting number and you mention like 3, so what it will do, it will show you the first 3 result starting from 0 till 0, 1, 2. So A, B, and C is your output. So this was about slicing. So next data type is list. These are a sequence of mutable Python object defined under square brackets. And since they are mutable, they can be changed. Let's move ahead and perform some operations on it and understand it in detail. Let's define a list. My list, and since I'm defining a list, it should be under square bracket, not in parentheses. So my list equal, let's define an integer, a floating point like 3.14. Let's define a string and a character. So this is my list. Let's move ahead and perform some operations on our list. So the very first operation is concatenation, that is adding element to the list. Just as we added in the tuple. So my list plus equal to, but here you have to specify it within square brackets. Like what do you want to add? I want to add extra element. There's my extra element. So extra. And yeah, don't miss the comma part over here. And let's check and verify whether our list is updated or not. So my list, when you execute it, and you'll see that you got this value extra as a part of my list. So next is repetition. Similar to what you perform in tuple, you can perform the same within the list. That is, you can repeat your elements within the list like this. My list multiplied by 2. So what basically it is doing here, it is just repeating your entire set of list. 1, 3.14, Python, A, and extra. And again, the repeated set of list, 1, 3.14, Python, A, and extra. Similarly, you can perform slicing on it. For example, I want to extract first 4 elements from my list. So starting from A, and it should go till first 4 elements. All right. So let's execute it. So as you can see, we got the output as 1, 3.14, Python, and A. The 5th element is discarded in this case. Similarly, you can do the same for last 3 elements. You can just write -1. So now, for example, I want to access the last element of my list. So how can I do that? So just write my list and in the square brackets, mention the index as -1. It will give you the last element. Similarly, for last 3 elements, you can do starting from 2 and it should end till last. So you can see that we got the output as Python, A, and extra. So these are the last 3 elements from my list. Next, we have another function as append. append adds its argument as a single element to the end of a list. When you're appending the value, the length of the list will itself increase by 1. For example, my list dot append add extra character B or extra character C in it, and let's print and check our updated values of my list. So now when you execute it, your list would be updated with an extra value of C. So there's my new updated list. So basically, append function was used to add an element to the list. Next is extend function. Extend concatenates the first list with the another list. For example, I've already defined a list, right? That is my list. And I want to extend with another list. Let's define another list as, suppose I want to add B and E to it. And let's print my list. And when you execute it, you'll see that B and E are extended to the list. See, there's an important question which is generally asked in the interview, like what is the difference between append and extend? So let me just resolve it for you. When you're using a append function, you're just adding a value to a list. And when you're using extend function, you're just merging two lists together. Next is the insert function. So what if I want to insert a particular value at a particular index? So how can I do that? So my list dot insert first would be the index number of the position where you want to insert. Like I want to insert at second position. Second, and next would be the value that you want to insert. Like I want to insert D. Now let's print the updated list. Let's execute it. So you can see that D is inserted at position 2, 0, 1, 2. So up till now, we have covered about numbers, strings, tuples, and list. And I hope that the difference between a list and tuple is clear to you guys. If not, let me summarize it again. Tuple is immutable while a list is mutable. Parentheses are used when you're grouping items under the tuple. And square brackets are used when you're defining a list. Well, these were some of the basic difference between a tuple and list. So let's move ahead and discuss about dictionaries. These are one of the most flexible built-in data type in Python. In this, the items are grouped under curly braces. The elements or the values are grouped together with a key value attached to it. The items are stored and fetched by key instead of by positional offset values. Or you can say that we are the one who define the index for the element in case of dictionary. So let's move ahead and explore various functions of dictionaries. So let me define my dictionary, for example, my dictionary, and how to define that using curly braces. So this is my empty dictionary. I can add items in it. And when you're adding items in it, as I told you that you have to use a key value pair. So this is my empty dictionary. You can define dictionaries with integer keys. For example, first is apple. Second is banana. This is my dictionary with integer key values. What is this? Dictionary with integer key values. You can even use mixed value key pairs in dictionary. Like, for example, name is John and something like 1 as an integer that equals, let's define a list into it, like 2, 3, and 4. This is also a dictionary with mixed key value pairs. Now, how will you access the elements from the dictionary? Now, suppose my dictionary equal my first element is something like word 1, comma, my second element is like word 2. Suppose this is my new dictionary. Now, how will I access my words from it? So how can I access my dictionary? So I can use my key values to access the element from it. For example, my dictionary, from that I want second element. For example, I want word 2 from my dictionary. So as I know that the key for word 2 was 2. So I'll just write my dictionary of 2. So it will return the word 2. Next is length. Now, what if I want to check the length of my dictionary? How will I do that? So what I want to do is length of my dictionary. So it will just result to 2 as I have two key value pairs in my dictionary. Now, what if I need to access all the keys from my dictionary? How will I do that? So there is a function as keys. So I'll just write my dictionary dot keys and hit run. So you can see that I got the output as 1 and 2, which are nothing but the keys from my dictionary. Now, what if I need the values from my dictionary? How can I do that? So similarly, I have another function as my dictionary dot values. And when you execute it, you'll get this set of values like word 1 and word 2. Now, what if you want to update your values in your dictionary? So for updating your values in a dictionary, you can use the function update. So it's like my dictionary dot update. Make sure that when you're inputting the updated element, just mention it under the curly braces, like 3 dot what I want to update it with, my third key with word 3. So when I'll print it, I'll get the updated dictionary. So basically this update method does not return any value. It just adds one dictionary to other dictionary. So basically when you're mentioning a value under update function, make sure the value is in a form of a dictionary. That is, it should be in a form of key value pair within curly braces. So this was all about the dictionaries. So now that we have learned about dictionary as well, so let's discuss about the last data type, that is set. So what is set? Set is defined as something in which the items are grouped together under the curly braces. Items are grouped together with an opening and curly braces. And you don't have to define a key value in it. It is basically unordered collection of items. If you're adding an element in the set, then make sure that every element in the set is unique and is immutable. That is, it cannot be changed. For example, let's define a set. So my set equals, just add curly braces like 1, 2, 3. This is a very basic example of a set, and my set is defined. This is how you create your set. You can even print it. My set, this is your set. You can also perform some union operation on it. Like let's define another set, like my set 2 equals 3, 4, and 5. And what I need to do is perform union. So let's perform the union of my set and my set 2. My set union using a pipe symbol and my set 2. So you'll get the result as 1, 2, 3, 4, and 5. So next is the intersection of two sets. So let's see how we can do that. So you can perform intersection of two sets, my set and my set 2, using the AND operator. My set and my set 2. Let's execute it. So you'll get 3 as a result, because 3 is the common element or the intersection of these two sets. You can even perform difference of two sets. So my set minus my set 2. So you got the difference as 1 and 2. See, the difference of two sets, what it is basically doing, it's showing all the elements which are part of only set A. They are not a part of set B. It's like you want only my set. You don't want any element from my set 2. So when you perform the difference of two sets, so it removed the 3. So you got the output as 1 and 2. So this was all about the data types in Python. Now that your base is clear, let's level up ourselves and discuss about flow control in Python. So these flow control are the one which controls the flow of your program. So we have if else, nested if else, for, while, break, and continue. Let's discuss them one by one. So the very first flow control in Python is if else. Let's understand it with the help of this flow chart. When it starts executing, the very first thing it does is check condition, if true or not. That is, if true or false. If your condition is true, then block 1 is executed, else block 2 is executed. So this is if else. Let me show you this with the help of an example. Let's take two input from the user, num1 and num2, and check which of these two numbers are greater. So print enter first number and store it in num1. Similarly, print enter the second number and again store it within num2. Now here comes the if part. If num1 is greater than num2, then what do you have to do? Then print %s is greater than %s. That is, num1 is greater than num2. Else, then print same %s is greater than %s. And in that, my num2 will come first, as in the else part, num2 will be greater than num1. So there's a program. Let's execute it. So enter the first number. Suppose my first number is 14 and enter my second number. Second number is 12. So 14 is greater than 12. So this is your output. Now, what if my second number was greater? So let's see. First number is 14, second number is 16. So you'll get the output as 16 is greater than 14. Let's see the execution of the program. Each line of the program is executing one by one. Like first enter the first number, then second number. In the if part, what it is doing, if it's checking the condition, if the number 1 is greater than num2, If this part is true, then the statement will be executed. Else, the next series of statement will be executed. So this was about if else. Next statement is nested if else. Nested if else is multiple if else statement used together. Let me just modify the same program. And let's include the third number as well. Print, enter the third number. So now you have to compare if number 1 is greater than num2 and num1 is greater than num3 and %s, that is num1 is greater than num2 and num3. Else elif. For else if we write elif. Again in elif part we have to write a condition. So else if number 2 is greater than num1 and num2 is greater than num3, then print num2 is greater than num1 and num3. Else print num3 is greater than num1 and num2. So include num3 equal input. That's why I'm getting an error like name num3 is not defined. So I'll include this part as well, that num3 equal input. Now let's execute it again. So enter the first number. My first number is 10. Enter the second number is 20. Enter the third number, it's 30. So I'm getting the output as 30 is greater than 10 and 20. So let's perform a dry run on it. Num1 was 10, num2 was 20, and num3 was 30. So num1 as 10 greater than 20, this was false. Num2 greater than num1, this was true. And num2 greater than num3, this was again false as 20 is not greater than 30. So the else part was executed like 30 is greater than 10 and 20. So this was an example of nested if else statement. Always remember that in if and elif part, there are a condition associated to it. But in else part, there is no condition. Else is the end result. When nothing goes right, then go with the else. Next is the for statement. Well, this for is basically a loop and is used for iterating the values. Let's see this with the help of an example. First of all, let's define our list. So my list would include apple, banana, and mangoes. Now that I have defined list, for x in my list. If x is in my list, so print x. That's it. And what it will do, it will print all the elements of your list. When you execute it, apple, bananas, and mangoes. Let me just give you another example of it. Now, what if you need to print a number from 1 to 10? Printing a number from 1 to 10 using for loop. So how will you do that? So there's a function in Python as range. Let's see how you can use that. For example, you can write for x in range 1 to 11. And inside this for loop, you have to write print x. And when you execute it, you'll see that you got the number from 1 to 10. The range function returns a sequence of numbers starting from 0 by default, and it increments by 1 and ends at a specified number. For example, if I just write for x in range and print the value of x. So it will take the number from 0 to 9. It will start from 0 and end before the number specified within the range. Well, this range function by default increments the sequence by 1. But however, it is possible to specify the increment value by adding a third parameter. Now let's move ahead and let me show you one more feature of this range. Now, what if you want to find all the even number between 0 to 20? So how will you do that? So in this case, you have to add one more parameter to range. That is by what value it should increment the number. Like for x in range, start from 0, go till 20, and then add the value by 2. Let's just print the value of x, print x. And when you execute it, you will see that you got a list of all the even numbers between 0 to 20. You can even write the ever program using the if else code, like for x in range till 1 to 20. So I'm mentioning 21. So x in range 21, and inside that I'll check if x mod 2 equal 0. So this indicates that it's a even number. If this condition is true, then print x. That's it. It's a even number. So you got a series of even numbers from 0 to 20. So this is how you can include if statement inside a for. Next is the while loop. Well, with while loop, we can execute a set of statement as long as the condition is true. For example, I want to print my number ranging from 1 to 10 using while loop. So how will I do that? So what I want to do is print all the numbers between 1 to 10. So 0 while I is less than or equal to 10. While I is less than or equal to 10, then in that case, print the value of I. And after printing the value of I, you have to increment the value of I by 1. That's it. And it's done. It's executed. You can update it with this from 1 to 10. So now you got the value as 1 to 10. Now what if I want to print all the even numbers between 1 to 10? So how will I do that? I'll start with I equal 1 and I'll check the condition while I is less than equal to 10. If the condition is true, then print the value of I. Then after printing the value of I, increment the value of I by 2. And that's it. And then execute it. But what you're getting here, you're getting a series of odd numbers. So this is wrong. So you have to start it with 0. So I equals 0. And now when you execute it, you'll get 0, 2, 4, 6, 8, 10. But since you wanted even number between 1 to 10, so you don't want this 0 part. So how can you remove that? Let's remove the 0 part as well. So just add a condition. If I is not equal to 0, then in that case, print I and increment the value of 2. And that's it. Execute it. So you will get the result as 2, 4, 6, 8, and 10. So this was something about while statement. Now let's start with break statement. So this break statement, it is used to stop the loop even if the condition is true. So let's see how you can do that. Suppose I want to exit the loop when my value of I equals 3. So how can you do that? Let's see in while loop first. For I equals 0, while I is less than equal to 10, print I, or you can check the condition at the beginning itself, like if I equal 3, then break, else print I, and then increment the value of I by 1. So what do you think the expected output would be? It would be 0, 1, 2. That's it. Now let's try the same thing using the for loop. So for I in range, first 10 numbers, if I equal 3, then in that case, break the loop. If not, then print I and increment the value of I by 1. Execute it, same result. So this was about the break statement. Next is the continue statement. This continue statement is used when we want to stop the current iteration and continue with the next one. For example, I don't want my program to break in. I want if I equals 3, then my program should continue. It should skip that part. So how will you do that skipping thing? So skipping I equal 3. So let's see how we'll do that. So let's first see that using while loop. So I equals 0 while I is less than 10 or less than equal to 10. Then in that case, I plus equal to 1. And once you have incremented, that is your 0 became to 1, then you will check for a condition. If current value of I is that equal to 3, if yes, then continue. If the current value of I does not equal to 3, then in that case, print the value of I. And after printing the value of I, then jump to the next statement, that is I plus equal to 1. Then finally, print the value of I. Let's execute it. If the value of I equals to 3, then continue that. What you're doing here is you are skipping the value I equal 3. Then finally print it. Let's execute it. So you'll see that 3 is missing. But can you see we are getting 11 also up here. So why we are getting 11 as an output? When we reach to 10, that is I equal to 10, the while loop, it was checking the condition that I is less than equal to 10. The condition was true. When the value of I equal to 10, then the next statement was while I less than equal to 10. The condition was true. Then what it did, it updated its value to I plus equal to 1. That is the value of I became 11 up here. That's why you're getting the value 11 here. When it checked the next condition, that is if I equal 3, it continued that anyways the 3 was not there. And finally it printed the updated value of I. That was nothing but 11. Then after updating the value to 11, again when it came back, it checked I is less than equal to 10. Obviously 11 was not less than or equal to 10. So the loop exited and you got the output. So this was all about the flow control in Python. Now moving on ahead, we'll learn about function in Python. So what are functions? A function is a block of organized reusable set of instructions that is used to perform some relatable actions. But why do we even need a function? What if you have to write a program in which you have to use same set of codes again and again? For example, you wrote a 16 line of code and those 16 lines of code are coming in your main program at 4 different places. So you have to write in total of how much? 64 lines of redundant code. So in order to resolve this issue, they created function. So function is a block where you write your code which you think you might use it again at some point of time. It allows reusability of the code and minimizes the redundancy. So next it is procedural decomposition makes things organized. But what is this procedural decomposition anyways? Well, a decomposition paradigm in computer programming is a strategy for organizing a program as a number of parts, and it usually implies a specific way to organize a program text. Usually the aim of using a decomposition paradigm is to optimize some metric related to program complexity. For example, the modularity of the program or its maintainability. This is why we are using functions in Python. In Python, there are basically two types of function. Now let's move ahead and see the types of function in Python: the user-defined function and built-in function. Let's discuss them one by one. So starting with the user-defined function. Well, user-defined functions are the one in which you create the function as per your need. Let's see how you can define a function. Function block begins with a keyword def followed by the function name and parentheses. These parentheses consist of any input parameters or arguments. Code block within every function is indented and starts with a colon. And finally, return expression is used to exit a function. A return statement with no argument is same as return none. So let me just show you an example of a function. So as I said, it should begin with the keyword def, followed by the name of the function, my function, and followed by parentheses and colon. So there's how you define your function. And inside your function, you can write anything what you want, like print, this is my first function. So this is an example of user-defined function. You can even add some parameter in your function. Like now let's define a function as add. It takes two parameters as num1 and num2 and returns the sum of both of them. So we'll define another variable as sum equals num1 plus num2. And then let's print the sum of %s and %s is %i. That is percent of, starting with first is num1, next is num2, and the third one is sum. So this is my addition function. So this is how you define a function. Now what if you have to call a function? Now that you have defined a function, you can call them as well. So what if I want to call it? So let's call my function. Calling the function. This was creating the function. So for calling the function, you don't have to do anything. Just add your parameters to like 12 and 13 and just hit. So yeah, the sum of 12 and 13 is 25. Let me show you one more, like my function without any parameters. Execute it. So there's my first function and this, it's working fine. Now, what if I want to define a function which returns some values like num1, num2? It takes two parameters and return num1 plus num2. That's it. I don't want to print any value or anything. I just want the result. And when you call it, let's see what it gives. This is my function. Now let's call this function. I'd add 12 and 13. So what do you think the output should be? 25. That's it. So now that you have learned about some user-defined function, so we can move ahead and learn about some predefined function in Python. You don't need to create them. You can just call them whenever you need it. Let me show you example of some built-in functions in Python. Some of the built-in function in Python include abs, which return the absolute value of a number, or ASCII that returns the readable version of an object and replaces the non-ASCII character with a bool, which returns the boolean value of a specified object. For example, abs. Let's check it out. For example, let's use a round function to round up the decimal parts of our number. So round 3.14. So you'll get the output as 3. So this was one of the example of predefined functions in Python. You can just go ahead and explore the other built-in functions in Python. Next is calling a function in Python. Well, there are two ways to call a function in Python. One is the pass by value, other is pass by reference. Let me start with pass by value. For example, let's discuss about by value first. Pass by value. Let's define a function. Define function 1. My function 1 has one parameter in it, b. And inside that, let's print the value of b is b. Now let's update the value of b to 100 and then again print like the updated value of b is again b. That's it. My function is defined. So this is your function. Now when you're calling a function by passing the value, so how will you do that? Function 1, just specify the value. It's like you're specifying the value of b. You mentioned the value as 10. So that is pass by value. Next is pass by reference. Let's see it with the help of an example. So what we are doing, pass by reference. Actually, at this point, we are performing this pass by value. So for pass by reference, let's define a function. Define function 2. Suppose it takes our input as c. Print the value of c is c. Now let me just modify something. Let me add some values for it, like c of 0 equal a number like 100. C of 1 equals 90 or something. So next, print the updated value of c is c. So my function is defined. Let's execute it. That's it. Now let's call our function by passing a reference value to it. So I'll call that. So function 2, and inside that I'll pass my reference as 12, 13, and 14. So let's execute it. So as you can see here, that I got the value of c as 12, 13, and 14, and the updated value was 100, 90, and 14. The value 14 didn't change as I have just updated the value of first two cells, that is 0 and 1. So this is how you perform a pass by reference. So thank you guys. This was all for this session. In case you have any doubt, feel free to add your doubt to the comment section below. And even if you think that I was not able to cover up some topics in this session, feel free to add that particular topic in the comment section below. I'll try to include those topics in my next video. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!